This research, produced by Bowtech Analysis on correlation, causation, and selection bias regarding e-cigarettes and smoking, was performed by Anna Choi from Sejong University and me, James Prieger, from Pepperdine University. This research was funded with a grant to Bowtech Analysis from the Foundation for a Smoke-Free World. The research and opinions I present are the sole responsibility of the authors. Regarding conflict of influence, I have consulted for firms in the tobacco industry in the past regarding ENDS and illicit trade. From 1980 to 2018, the prevalence of smoking among men in Korea declined from 80% to under 40%. Despite this achievement, the overall smoking rate in Korea remains above the median for all countries, and male smoking prevalence is still among the highest in the world. The reduction in smoking in Korea has been accomplished largely by means of the standard tobacco control playbook: tobacco taxes, publicly provided cessation services, smoke-free laws, and so forth. However, there is evidence suggesting that the efficacy of at least some of these policies is decreasing. For example, after the last large tax increase in 2015, the smoking rate dipped for men, but the following year it rebounded. There is yet much room to further reduce smoking in Korea and improve public health, and new approaches to encourage cessation from smoking should be considered. The widespread availability of e-cigarettes, ENDS, and heated tobacco products in recent years are the most innovative aspects of Korea's recent experience with tobacco, nicotine, and cessation. It is highly likely that ENDS are significantly less harmful than cigarettes. ENDS have also been found to aid cessation in some studies, including randomized controlled trials. What promise might ENDS hold for the harm reduction and cessation from smoking in Korea? In contrast to an increasing body of international public health experience and literature, the Korean government has made it known that it considers ENDS to be just as harmful as cigarettes, and that ENDS should not and cannot be used for cessation. As a result of negative views about ENDS by the government and the media, ENDS use is low in Korea compared to many other countries. Korean tobacco policy also fails to differentiate meaningfully between ENDS and traditional tobacco products in terms of taxes or most regulations. This removes important incentives for Korean smokers to reduce the harms from their mode of nicotine consumption. This might represent a massive lost opportunity to reduce smoking at a time when its decline has slowed. The government's stance relies in part on the fact that many ENDS users also smoke, making it appear that ENDS lead to smoking, support the smoking habit, or hinder quitting. However, the positive correlation between ENDS use and smoking is not likely to reflect a causal link, on average, since unobserved factors that increase the likelihood of smoking may also increase the chances of using ENDS. Investigating this was a major part of our research effort. Our evidence for such selection effects in who chooses to use ENDS comes in several forms. First, we compared data before and after a highly publicized negative government report on e-cigarettes and a tax increase on them in 2015. We find that the demographics and health behavior of ENDS users changed in ways unfavorable to cessation. This is evidence that the government's negative messaging about ENDS changed who was using them toward those finding it hardest to quit smoking. Second, the positive correlation between ENDS and smoking also rose markedly. Third, estimation of an econometric model designed to correct directly for sample selection bias shows that ENDS may indeed causally improve the likelihood of quitting smoking. In particular, we had estimated econometric models for endogenous treatment effects to correct for that selection bias. Our framework goes by many names in the econometric literature, but basically it is a double binary dependent variable system, two main equations. It's recursive in the sense that the e-cigarette usage appears in the equation for cessation, but not vice versa. And it is a linear index threshold crossing model in the same way that a probit or a logit is. So in the equations here, you can see that the first pair are to describe an individual's behavior regarding the propensity or whether they actually use e-cigarettes. The second pair of equations is for the outcome equation. And so when we speak about treatment using the treatment effects literature nomenclature, that refers to using e-cigarettes or not, and the outcome has to do with cessation, quitting smoking. The observation rule is that the dependent variable y equals 1 if the person had smoked at some point in the past, but has now quit smoking. The quantity of interest that we are trying to estimate with our modeling is the average treatment effect on the treated, or the ATET. This is the causal impact of e-cigarette use on the likelihood that someone has quit smoking among those who chose to use ENDS. And so this is not the average treatment effect across the whole population, because that would be more relevant if we were thinking about randomly sprinkling e-cigarettes throughout the population. Instead, we have to respect the fact that people choose to use them, and we want to estimate the treatment effect for such people. We estimate many versions of this model. One is a bivariate probit model that has independence between the two equations. This would assume away selection effects and is our base case. Then we do a bivariate probit model with allowing for unobserved confounders to be captured by the error terms in the two latent equations. This allows for selection effects. And then finally, we re-estimate versions of that two-equation model using copula modeling to check the robustness of the assumptions. So here are the first set of results. In these models, we are trying to estimate the average treatment effect on the treated, recall, which specifically is how does the probability of cessation change with e-cigarette use due to the causal effect. Now, in these specifications here, I know that there are a lot of numbers, but note that in the first row, the simple probit model that assumed away selection effects finds that ENDS use, quote, leads to less cessation. That's the negative ATET of negative 0.147 that you see there. However, in every other model that allows for selection effects, the ATET switches sign, and significantly so. There are many models here. Let me just say that we use formal information criterion, the design-based AIC measure, to pick a best model. And that best model is one of the copula models down there at the bottom. And our estimate of the causal effect from this model of using e-cigarettes on cessation is 16.2 percentage points. We also estimated a second set of models using the so-called potential outcomes specification. This essentially allows all the coefficients in the outcome equation to take different values depending on whether the person uses e-cigarettes or not. And so these models nest the simpler models on the previous page. And again, we modeled things many different ways. Note again that the treatment effect is estimated to be positive and statistically significant in all cases. And again, using our design-based AIC measure, we are led to that Clayton copula model as the best specification, and a result remarkably similar to before, about a 16 percentage point impact on promoting cessation, we estimate, from using ENDS. And then we estimate a different model down at the bottom. It's not a likelihood-based model, and so we can't directly say which one is better by the AIC measure. This is a control function model. It's a generalized method of moments estimation method. Details are in the paper, but again, a completely different method, but we find a very similar result, this time about a 17 percentage point impact on cessation from using ENDS. In summary, there is evidence that the individuals least likely to quit smoking are those taking up ENDS in Korea. Second, unobserved confounding factors associated with more ENDS use and more smoking account for the positive correlation observed between the two. Third, correcting for the observed and unobserved differences between ENDS users and others reveals that ENDS may help smokers achieve cessation. And four, there is therefore a potentially severe selection bias in any observational study of the association between ENDS use and smoking. Thus, the common belief among public health officials in Korea that ENDS use is hindering cessation is likely based on faulty conclusions drawn from inadequate analysis of the data. And now I leave you with a few brief policy recommendations. First, evaluate the impacts of tobacco control practices and ENDS usage with appropriate methodology, especially if one intends to make statements about causality. Second, consider and study the role that ENDS can play in harm reduction for adult smokers. Thank you, and I look forward to your comments and questions now.